So we're going to start on the graph paper. Title is Coordinate Rotations. And we are going to start with number 3. And you just need to draw on your graph paper a y-axis and an x-axis. And then we're going to plot the point A, which is 2, 4. So yesterday we learned what a rotation was. It was our new transformation. And that's when you take a figure and you have a reference point called a center and you rotate it down so things are moving in circular motion. Okay, we had translation a while ago, which was a slide. We had reflection, which is going across a line. And then our third transformation yesterday was a rotation, which is a circular motion around a center. Okay, so now we're going to rotate on the coordinate plane where we have some points. And the center of rotation is going to be the origin. So everything's going to rotate around the origin. And the first thing you need to know is this way is positive and this way is negative. All right, so first thing we're going to do is we're going to use our transparent paper, patty paper that you got there, and I'll just use a sheet of paper. And you want to put it on top of your graph where you have the point A, and then you want to put your finger on the origin so that you can turn everything around the origin. So your finger is kind of the fulcrum, place where you turn around. Okay, so then look through the patty paper and mark the point A on your patty paper. And what we're going to do is we're going to rotate this 90 degrees. So that's 1/4 of a turn. Okay, so here's A originally, and I'm going to rotate it positive 90, that's this way, 1/4 of the way. So from there to there. And then you got to figure out where A ends up. So it was at 2, 4. And then it should end up, well, where are you getting? Where's your A ending up? Down here. Like right here. So what point is that? Yeah, Judith? Negative 4, 2 is correct, but it's a little bit tricky. Is everybody seeing that? So it went from there to there. And that's negative 4, 2. So the A prime, the original A was 2, 4, but the A prime is negative 4, 2. Okay, so we're going to keep track of this. We had the point A at 2, 4, and then we rotated 90 degrees, and it ended up at negative 4, 2. We had our point A, rotated 90, ended up back here at negative 4, 2. Is everybody seeing that okay? Okay, now we're going to try a different point. You don't have to erase your points, but I'm just going to get rid of these so you can see better up here. So now B is going to be negative 3, 5. So B is the point, negative 3, 5. So put your patty paper back down there. Put your finger on 0, 0, because 0, 0 is the center of rotation. And trace where the point B is. And then we have to go positive 90, so that's this way. So try to see where B is going to end up if you go 1/4 turn this way. So what are you getting for B prime? Yeah, Maddie? Nice. Negative 5, negative 3 is right. Is everybody else okay with that? It's a little tricky.
I got negative 4.
So it could be it just kind of shifted on you a little bit when you turned it. Okay, now we're going to try another one. This time I'm going to have it, the original point be down here in quadrant 3. So let's go with negative 1, negative 2. That's C. Okay, so negative 1, negative 2. Finger on 0, 0. Positive 90 is this way. So 1/4 turn this way. So it should end up there. What are you getting?
2, 1.
It's down though, so 2, negative 1. You see that? Did that one work out better, Kieran? Cool. So 2, negative 1. Okay, so we've done 3 of these, so that's probably enough to figure out the pattern. What's going on here? Yeah.
The X and Y are flipping, and then the X is turning negative or positive.
So first of all, the numbers are switching places. Like 1, 2 is 2, 1, 3, 5 is 5, 3, 2, 4 is 4, 2. And then second of all, this number is changing to opposite. So 4 is going to negative 4, 5 is going to negative 5, negative 2 is going to 2. But this one's staying the same. So we'll put that on the note card eventually. A 90-degree rotation, the X's and the Y's swap, and the first number stays, second number switches to opposite. Okay, so that's a 90-degree rotation. So leave that on your paper, but just so we can focus, I'm going to change this, get rid of this so you can look. So now we're going to do a 180. How far do you have to go to do a rotation of 180? Is it all the way around?
Halfway around.
Halfway around, right? Because all the way around is 360. So 180 is half the way around. Okay, so let's go back to 2, 4. So that's the point A. And now I'm going to go halfway. So a 1/4 turn and then another 1/4 turn. half the way around, so it ends up down here. So this rotated all the way to there. What are you getting? Yeah, Maddie? -2, -4 is correct. Good. Might be a little soon to talk about patterns, but maybe not. What do you think is going to happen? They're going to all go to opposite and stay in the same place. So -3, 5 is going to be 3, -5. And -1, -2 is going to be 1, 2. So no swapping now, just oppositing. So that one's easier to see, so I think 1 is enough to sort of establish the pattern. You okay? Okay, now we're going to do 270. Okay, so back to original. 270 is 90 plus 90 plus 90. So it's 3/4 turns. So 1/4 turn, 2/4 turns, 3/4 turns. So 270 is from here all the way to there. 3/4 of the way around. What are you getting for A prime? +4, -2, good. I'll probably better do another one before we guess at the pattern. So -3, 5. Bless you. There's my -3, 5, and I'm going to do 3/4 turns. Here's B. So 1, 2, 3. So it ends up over here. Should have been +5, +3. Is that not working out for you?
That's fine.
Are you sure?
Yeah.
You're just going to take my word on it?
Yeah.
Okay. Okay, so what's going on here? What's the pattern? They're swapping, right? And also, which one's becoming opposited?
3.
The first number.
Oh,
Yeah, so -3 went to +3, +2 went to -2. Okay, last one. Now we're going to do -90. So this is our first negative. Okay, so let's start with A. So back to A. Positive is this way. So negative is this way. And 90 is 1/4. So we're going to go 1/4 turn this way. So 2, that A ends up back down there. So it's here again at 4, -2. So that makes sense, right? Because if you go 3/4 of the way this way, wouldn't that be the same as going 1/4 this way? Let me say that again. If you go 3/4 this way, that would be the same as going 1/4 that way. So that's why a negative 90 is the same as 270. Okay, so we're ready for the note card now. This is number 18. And it's coordinate rotations. And a rotation is also known as a turn. And when you rotate something, it ends up the same size and shape as it was originally. So it's congruent. So it's called a rigid transformation. So a rotation is a rigid transformation. We might have written that down too yesterday. So we've had 3 transformations. Translation, that one was rigid because if you just slide something, it's going to end up the same as what it was. Reflection, that was also a rigid transformation. And then rotation is a third transformation that is also rigid. So all 3 of our transformations so far have been rigid, meaning the final figure is the same size and shape as what we started with. Okay, then if it's a positive rotation, that's the opposite of a clock, so it's counterclockwise. So it goes, positive is this way, opposite of a clock. And then negative is clockwise, same as a clock. So that's kind of weird that clock seems normal to us, so it seems like that should be positive, but it's not that way. Clock normal to us this way is negative. If you go this way, like a clock, it's negative. Yeah.
That actually makes sense, because if you, like, at 12 a.m., you start counting down, and you start counting up again when it comes to 12 down, so that kind of makes sense.
Okay.
So,
All right, so then we have some patterns for rotations. So if you do a 90-degree rotation, that's what we were talking about on the sheet, and you start with a point x, y. So I erased those, right? So let's see, that was, what was this A prime? Negative 4, 2. So the pattern was that they swapped and the second number was opposite. So xy is going to go to yx. And then the y is the one that opposite it. So that was a 90. Then a 180 was a lot easier. Everything stayed in the same place. XY stayed XY. Just the stuff was opposite it. So xy went to negative x, negative y. You can see that. You can see it on your paper. 2, 4 went to negative 2, negative 4. Negative 3, 5 went to 3, negative 5. So 3, -3 to +3, +5 to -5. So everything's opposite when you do a 180, a half turn. Okay, then we did a 270, which was a 3/4 turn, and that was the same as -90. And that one was swap, and the second number is opposite it. Okay, back to the graph paper, and we're going to start with number 6 on this. I'm going to do a couple more with you at the board. So look at the back, number 6. So triangle ABC is, the original is 2, 3. You don't have to write this down because it's already written down. The original is 2, 3, 4, 6. And 9, 1. And then it says it's rotated -90. And they want to know what the new points are. So you have to write down the new A, and the new B, and the new C. Okay, so if you go -90, that's this pattern here. So the numbers get switched, and then the X is opposite. So this is going to switch to 3, 2, and the 2 is going to be negative. And this is going to switch to 6, 4, and the 4 is going to be negative. And this is going to switch to 1, 9, 1, -9. Okay, so all you had to do was use that pattern to switch them and make them negative. Okay, then it also says what quadrant is it going to be located in. Oh, I meant to put that on the note card. Sorry, I forgot about the quadrant. So go back to your note card. This goes on the back. So we got y-axis and x-axis. And when you have this divides it into 4 parts. They're each called quadrants. This is quadrant 1, and they use Roman numerals for them. This is number 2. Then down here is 3. And then over here is 4. And 4 is IV, which is weird in Roman numerals. So they're numbered 1, 2, 3, 4. Okay, so the original point was at 2, 3 in quadrant 1. And then we rotated it 90, actually -90. So we rotated it -90. So if it's in 1 and it goes -90, where does it end up? 4, right? Okay, so 6 was also saying what quadrant do these points end up in? So it's quadrant 4. Okay, number 7, the original points are, you don't have to write down the original points, that's part of the problem. There's the original points. So we need to, our job is to give the image points, x prime, y prime, and z prime. And this time it's being rotated positive 90. So with a positive 90, they swap, but this number gets opposited. So it's -4, -2. And -7, -4. So we're switching and oppositing that number. Okay, so originally it was -2, 4. So originally it was over here in quadrant 2. And it got rotated 90 to there. So now it's in quadrant 3. Okay, one more I'm going to help you with. This is number 13. The original point is 5, -2. And this time we've got a translation. So it's translated, so this is back to just sliding it. So what's happening to the x? Subtracted by 6, right? So the 5 is going to become -1. And then the y is being added by 4. So the y is going to become +2. So this is my original point, and then after I slide it, I end up here. Okay, but then something else is happening. Then it's rotated -270. Okay, so negative is this way. So it's 3/4 this way, right? -270. That would be the same as +90. If you go -270, it's the same as +90. Okay, so we're going to use the +90. So the x and the y switch.
So,
Yeah.
-2, -1.
Nice. So these swap and that one opposites. Okay, then this is a crazy problem. There's one more thing that's happening. It's reflected across the y-axis. Okay, now here's what throws everybody off. When they see the word y-axis, they think the y is going to change. But actually what happens is the x changes. So this -2, 1 is going to be 2, -1 after a y-axis reflection. Okay, so this was kind of combining everything. We did a translation to get there, so it slid. Then we did a rotation, so it turned. And then we did a reflection across the y-axis, so it went to there. So all three things happen: slide, rotate, reflect. So that's where it was after it slid. That's where it was after it rotated. That's where it was after it reflected. All right, thanks for listening.